Hello everyone, Shahin is here. I have been asked by a couple of students to make a demonstration file for this task 2 tolerances. So some people found this tolerancing thing difficult to follow. So the solution is you've been provided by a disk, and this disk has 3 pins, and you have to design two type of rings. The first type is that which fits the 3 pins and it is not concentric with the major disk, and the second design is a ring which is tangent from inner ring to these pins, and at the same time is concentric with the big disk. So that is very simple compared to the sketches that you have made before. The trick is you just go to this drawing. The drawing indicates the center of the pins. So the center of the pins are fixed, they are not supposed to change. The only thing that changes is diameter of these pins. So these are D1, D2, D3. So smallest one is D2, the medium one is D1, and the largest one is D3. So look into these tolerances, and so you want to apply all these combinations to these diameters, and no matter what combination is there, you want the inner diameter of the first ring and second ring to fulfill the condition. The conditions are: first condition is the inner ring of the first one should tangent to these 3 pins in the worst case scenario, and if that fits for the extreme case, that would fit for the rest of the cases. So the extreme case is to have these diameters under the smallest size. So if they are small, the worst case scenario is to get the largest diameter of these pins, because with the largest pins you would have the largest inner diameter of the ring, and if that fits for the worst case scenario, in case if these pins are a little bit smaller, still that would fit. It won't clash with these pins. The second design is you want to design a ring or an inner diameter of a ring which only tangents to this one, to the outmost pin, and at the same time is concentric to this one. Again, if you apply the largest diameter of D3 to here and then make a hand-free circle, make that concentric with the large circle, and that give you the estimation of the inner diameter. And once you have the inner diameter for the first design or second design, all you have to do is apply the thickness. So here I'm going to demonstrate to you what happens. So with this solution, you have to consider the worst case scenario, and for the worst case scenario I can design the inner diameter of the first ring once this is tangent to these 3 pins, and the size of the 3 pins I applied the largest possible diameter given the tolerances. So once I get this one, I add a radial thickness to this one, and the radial thickness doesn't have any tolerance. So that is would tell you the volume of the first design, first ring. And with the second one is very similar, and all you have to do is you just apply the largest diameters, and then you construct the inner circle of the ring and apply the condition of that inner diameter to be tangent to the outermost pin. So that would make the inner diameter of the big o-ring, and then you add a radial thickness to that. The radial thickness doesn't have any tolerance, and then that's all it takes to make them. And then just to check your solution, I'm looking to the weight of the o-rings or rings, and all you have to do is you have to assign the material nylon 101 to these rings, and in the second instance you assign the material of aluminium 6061, and that SolidWorks can calculate the mass for you. Just this is inside the tools mass properties. Into evaluate, you go to the tools evaluate and then mass properties. After assigning the material, you would be able to estimate the weight of the ring. So I hope this demonstration make things more understandable for everyone, and if you have more question I can address this for you in our next computer lab. Thank you for listening.